All right, hi guys. So for your video notes, you want to go ahead and title this Unit 10, Lesson 1B, Composition of Functions with Tables and Graphs, okay? So last time you should have reviewed the composition of two functions using their formulas. So today it's also including here tables, so tables and graphs. Okay, so just as a review, remember with composition functions, we have one function such as g of x and then another function f of x, right? And so what it means is whatever is the output value, right? The output value of one function ends up being now the input value for a different function, right? And ultimately getting a new output. Okay, so I'm going to go over how to do this with a table, which is a little bit more complicated, and with a graph as well, with a set of two different functions, which is a lot easier than the table. So let's start with something tougher. All right, so when you have something like this, that means you have one function, f of x, g of x, and then here we have a composition of those two functions. For the sake of kind of clarity of this problem, I'm going to call this h of x. All right, so let's go ahead and solve for the variable b here to start us off. All right, so the way we would do that is by figuring out a little bit of notation here. So because we're calling this h of x is the same as g of f of x. All right, and basically we want to figure out, so again, we're not calling this g of f of x, we're calling it h of x, but it was originally g of f of x, okay? So it's the same thing, so they're equal. So basically, it's like we're figuring out, what's this whole output value when our input's 2, right? So let's say, for example, this, right? H of 2, which is the same as g of f of 2, right? And so we want to figure out f of 2, which we can because f of 2 is given right here, right? And how do I know that? Well, this notation is the same as f of 2, right? So, hold on, I need to pause my screen real quick. I wonder if I can just do this. All right, sorry guys. So I just got like some food from DoorDash. Anyway, so here we say f of 2, right, is equal to 1. All right, so I'm basically, let me give this a green color. So that becomes now my g of no longer f of 2, that is f of 1, right? And now we figure out, well, what is g of 1, right? So g of 1 is located, g of 1 is located here. So now we can say this is equal to, so g of 1 is equal to 1. So ultimately, the final answer, h of 2, which is the same as g of f of 2, is equal to 1. So our answer here is 1. All right, that one's a little more straightforward. Now let's do something a little more complicated, which is a. All right, so here, this one's a little bit different because we want to figure out what is g of 2, right? So to figure out a, it's going to be g of 2 equals a, right? So this is tough because we don't have something to look beforehand or anything like that. So all we have is this third column, and we're going to use this third column to help us figure this out. So we know in the third column we have g, hold on, I'm going to make this black. We have g of f of x, okay? So here, I know that this input value is going to be the same thing as whatever the output value is for f of x, okay? So we have to think backwards, okay? We were thinking about like what output value, right, is going to, or hold on, let me do it like this. Sorry, what input value is going to give us 2, because that's what we want here. Like this same 2 in green right here is the 2 that we want to figure out. So we have to look back on our table and see, what input value will give us 2, okay, but for the function of f. So we look in here on our table and we can see that the output value for 2 right here occurs when the input is 0. Okay, so we can say here f of 0 equals 2. All right, so here we can now write this as g of f of 0. All right, so g of f of 0 is now the same thing to figure out g of 2. So let me rewrite that over here. G of f of 0 equals the same thing as g of 2. And remember, how do we know that? Well, f of 0 is 2. Okay, so that means the input is 0 in this case. So that means whatever this is, g of f of 0 it's the same as writing h of 0, right? Because remember, we changed it to h of x. Okay, cool. So this one's, like I said, it's a little bit more backwards and kind of confusing, but now we can figure out h of 0. H of 0, in this case, g of f of 0 is equal to 2. So ultimately, to figure out g of 2, we had to go backwards with this process. And so now we have g of 2 is equal to the number 2, okay? So here a is equal to 2. All right, I'm gonna show you again another example in this problem. Hopefully it'll make a little bit more sense. I'm gonna erase this. Hopefully you can copy it before I erase it. Cool, so let's start with something easy. Let's start with the variable d. Okay, so we're solving for d. So the way to start this off, we are figuring out what is, remember d is also written as h of 1, and the same thing here, e is the same thing as h of e, and this one is the same as f of 2. Wait, hold on, that's confusing, not h of e. My bad. That's the same as h of 2. Okay, cool. So just know that that notation is the same. All right, so let's solve for d. So we know h of 1, right, is the thing we're looking for. We're looking for the output. What output is it? What output value is it when the input is 1? Okay, so cool. So here, remember h of 1 in this case, our h of x is equal to the same as f of g of 1. All right. And then we just basically find missing parts of the puzzle. So g of 1 is the same, g of 1 is the output of 0. So we write 0. And then f of 0, so we go to our f function, input is 0, the output ends up being 1. Cool. So we get h of 1 equaling 1, which is the same thing for d. So in this case, equals 1. Okay, so d equals 1. Cool. So we figured that one out. So let's try e. E is the next easiest one. So e is the same as figuring out what is the output value when the input's 2, right? So h of 2, remember, given our equation, or our compositional function here, h of 2 is the same as f of g of 2, because the input has to be the same. Now we just solve individually, or find the output value that goes with the input for g of 2. So we look at our g function, our input is 2, our output ends up being 1 when it's g of 2. So we write now 1, right? Okay, now we're going back to our f function. So we have our, we look at this column, and our input is 1, and our output is 9. So that means we get 9. Okay, remember all of these are equal to h of 2, which is the e value that we're looking for. So we end up here and we stop here. So our value for this is 9, okay? So that one's easy. Now we look to find the value of c. Now this is the one that kind of looked like this problem over here. So we have to go backwards for this one, right? So we have to think about f of what, right, is going to give us, oh wait, no, my bad, f of 2 equals c is what we're looking for, okay? So to figure that out, we can use this composition function to help us, okay? So we know, given this situation here, okay, we know that what's going to be inside the parentheses here has to be 2, right? Because it's f of something. So the something that we're looking for is 2. So we have to figure out as well, okay, just looking at that portion, what input in the g function is going to give us the output of 2? So we have to look through our g function. What input is going to give us the output of 2? Here's the output 2. It's going to be 0. Okay, so we can say g of 0 is going to give us 2. So we know here, okay, this is now g of 0. All right, and remember, this is important because now when we simplify this, g of 0, we've already stated that it's the same as 2, so that's f of 2, right? And that's the one we're trying to figure out, and f of 2 is equal to the value of c, which we're trying to figure out. So now we think about, okay, going backwards using our compositional functions, this is the same as h of x, right? So what this input value is, this has to be the same because these are being composed. So here, this also has to be 0, okay? So now going backwards, h of 0 is equal to 5. So we can say h of 0, which is the same as f of g of 0, which is the same as f of 2, which is equal to the unknown that we're trying to figure out, which ends up being 5. And that's our answer. Okay, so this would be equals 5. Okay, cool. That was a more complicated one. Now something a little more straightforward. We are finding the composition of two functions using two graphs. So given below are the graphs of two functions, f of g. Use the graphs to estimate each of the following, okay? So we're just going to estimate the values here. And we can clearly see f of x is a parabola, or maybe a part of a polynomial maybe. And then g of x is a linear function, okay? So here we have f of 0. So f of 0 ends up being remember this is our input, right? So we want to figure out what is f of 0. So here we have, again, 1, 2, and 3. And so f of 0 is the same as this point here on the function. And that we're going to estimate. So that's approximately like 2.8, right? So now we write 2.8. And then we figure out, okay, what is g of 2.8? Okay, so g of 2.8 ends up being Now our input is 2.8. So we go to 1, 2, 3. So 2.8 is somewhere right here. We go all the way until we reach a point on our graph. And we can see that the output is going to be a negative number. Wow, that's so bad. Sorry, guys. And so that's going to be approximately negative 2.3. Okay, so our answer here is negative 2.3. All right. So we do the same process here, g of 0. So our input is 0, and then we go to that point. So it's at negative 1. So f of negative 1. We find f of negative 1, which ends up being right here. So again, negative 1. And we go all the way. We find our output by finding what point does it work with, or does it intersect with the with our function. And then, so it's a little less than 2.8. So we can say 2.4. Okay, so f of negative 1 is 2.4. Cool. Do the same thing for g of 3. G of 3, so we find g of 3, so our input is 3, and our output, given that this is a little lower than this one, should be a negative 2.5. So we can say f of negative 2.5, and then we use that input, right, to match with that intersects with the point here on our f of x function. And so that's going to give us approximately 0.9. Cool. Let me use this dark purple, so, or blue, g of 4. So we find g of 4, so our input 4, right? And if we go down, we can see that it intersects with negative 3. So that ends up being g of negative 3. And we go to negative 3. And then remember, we're dealing with our g function, which is the linear graph. And then we can see that it's a little less than negative 1, but a little less than our pink value, which is 0.9. So we can say this is 0.5. Okay. And then same thing for f of 1. So I'll use green. F of 1, so our input is 1. And we go to our f of x function. So that's somewhere right here. So we can say it's 2.8. It's pretty similar. So that's f of 2.8. And then we find 2.8 again. 2.8 is right here, right? But instead of going to our linear function, we go to our quadratic. And so it's a little bit bigger than 1. So we would say 1.3. Okay, so that one's a little bit faster. Cool. All right, so that's how you interpret composition functions or composition of two functions in a graph as well in a table. All right, and that's it.